Close your eyes and breathe deeply, slowly, letting all the tension flow out of your body like stardust dispersing into the void. Feel yourself becoming lighter, weightless, free from the pull of gravity, free from the weight of worry and stress. You find yourself floating in the most peaceful darkness you've ever experienced. It's not the darkness of fear or uncertainty, but the gentle, velvet darkness of deep space, infinite, calm, and infinitely peaceful. You are completely safe here, cradled by the universe itself, held gently in the vast expanse of cosmic peace. Around you, stars begin to appear. Not suddenly, but gradually, like eyes opening one by one across the darkness. First a few, then dozens, then hundreds, then thousands, then millions, until you're surrounded by more points of light than you could ever count. Each star is a sun, burning with ancient fire, sending light across impossible distances to reach you here, now, in this peaceful moment. The stars don't twinkle here as they do from Earth. In the absence of atmosphere, their light is steady and pure, white, blue-white, yellow, orange, and red. Some shine so brightly they seem close enough to touch. Others are distant and faint, their light having traveled for thousands or even millions of years to reach your eyes. You're not cold, though space is cold. You're not struggling to breathe, though there is no air. Somehow, you are simply here, existing peacefully in this vast expanse, a conscious awareness floating among the stars. You feel perfectly comfortable, perfectly safe, perfectly at peace. You begin to drift, moving slowly through the star field, though you're not sure if you're moving forward or if the universe is moving past you. It doesn't matter. The effect is the same, a gentle gliding through infinite space, surrounded by beauty and silence and peace. The silence of space is profound, deeper than any silence on Earth. There is no wind, no water, no rustle of leaves, no distant traffic, no hum of electricity, just pure, absolute silence. And in that silence, you can almost hear something, not a sound exactly, but a presence, a vibration so deep and so slow that it's felt rather than heard. The cosmic background radiation, perhaps the echo of the Big Bang itself, the first sound ever made, still resonating through the universe after nearly 14 billion years. You pass through a region where nebulae bloom like flowers in the darkness. These are stellar nurseries, vast clouds of gas and dust where new stars are being born. The clouds glow with colors that seem impossible, deep reds and pinks from hydrogen, blues and greens from oxygen, golden yellows from sulfur. The shapes are organic and beautiful, pillars and wisps, shells and ribbons, sculpted by stellar winds and radiation into forms that resemble nothing and everything. You drift closer to one nebula, and its scale becomes apparent. This single cloud is light years across, so vast that it would take beams of light, traveling at 186,000 miles per second, years to cross from one side to the other. Inside the cloud, you can see points of brightness where new stars have just ignited, their light beginning to push away the gas and dust from which they formed. Some of these stars are surrounded by disks of material, protoplanetary disks, the raw ingredients from which planets will form. You're witnessing the birth of future solar systems, seeing the same process that created our own Sun and Earth billions of years ago. The thought fills you with a sense of connection, of being part of something vast and ancient and ongoing. You continue your drift, leaving the nebula behind, watching it shrink until it's just a colorful patch against the darkness, then a small glow, then indistinguishable from the countless other nebulae scattered throughout the galaxy. Ahead, You notice a particularly bright star, blue-white and brilliant. As you approach, you realize it's not just one star but two, a binary system, two stars locked in an eternal dance, orbiting their common center of gravity. They spiral around each other gracefully, their gravitational embrace unchanging for millions of years. One star is larger and brighter, the other smaller and dimmer, but they're partners in this cosmic waltz, bound together by invisible forces, moving to a rhythm measured in days or weeks or months. You watch them for a while, mesmerized by their motion, by the simple beauty of their dance. Then you drift onward, deeper into the star field. You pass a red giant star, old and swollen, its outer layers expanded to enormous size as it nears the end of its life. The star is beautiful in its own way, deep red-orange, like a glowing coal, its surface turbulent with convection cells the size of planets. In the cosmic future, thousands or millions of years from now, this star will shed its outer layers in a planetary nebula and leave behind a white dwarf, a dense ember that will slowly cool over trillions of years. But that's future time, cosmic time, time measured in millions and billions of years. Here and now, the star simply glows, ancient and peaceful, a monument to the stellar life cycle. You notice planets orbiting some of the stars you pass. Most are distant and small, visible only as tiny dots, but occasionally you drift close enough to see details. There, a gas giant, banded with clouds in shades of brown and cream and orange, a massive storm visible as a dark spot in one hemisphere. 3 moons are visible, small worlds locked in orbit around their giant companion. And there, a terrestrial planet, rocky and barren, its surface cratered and ancient, untouched by wind or water for billions of years. No life has ever emerged here, but the planet is beautiful anyway, a work of geological art shaped by impacts and volcanism and time. You drift past a solar system similar to our own, a yellow star surrounded by a family of planets. The inner ones are small and rocky, the outer ones large and gaseous, with asteroid belts and comet clouds separating the different regions. You wonder if life exists anywhere in this system, on one of those rocky inner worlds or perhaps on a moon of one of the gas giants. But you're too far away to know, and you drift onward, leaving the question unanswered. The stars around you begin to thin out, and you realize you're leaving the dense star fields of the galactic disk and moving toward the halo, the spherical region of older stars that surrounds the main galaxy. The stars here are redder, older, metal-poor stars that formed in the early days of the galaxy, before generations of supernovae had enriched the interstellar medium with heavier elements. And then, as you drift farther, you begin to see it, the galaxy itself, spread out before you like a cosmic work of art. From inside the galaxy, you could never see its full shape. But from here, outside and above the galactic plane, you can see the entire structure, a vast spiral, hundreds of thousands of light-years across, containing hundreds of billions of stars. The spiral arms curve gracefully outward from the bright central bulge, like cream stirred into coffee, frozen in the act of mixing. The arms glow with blue-white light from young, hot stars, and pink from emission nebulae where new stars are forming. Between the arms, the light is more subdued, yellower, from older, cooler stars. The central bulge is brightest, a dense concentration of ancient stars surrounding the supermassive black hole that lurks at the galaxy's heart. The black hole itself is invisible, but you can see the effects of its gravity on the stars around it, their orbits impossibly fast, driven by the immense gravitational field of the darkness at the center. Dark lanes of dust thread through the spiral arms, blocking the light from stars behind them, creating patterns of light and shadow that give the galaxy depth and structure. The dust is cold and dark, but it's not empty. Within these dark clouds, new stars are forming, continuing the cycle of stellar birth and death that has been ongoing for billions of years. You float here for a long time, simply watching the galaxy slowly rotate. The rotation is so slow that even from this perspective, you can't actually see the movement. It takes hundreds of millions of years for the spiral arms to make a complete rotation. But you know it's moving, know that everything is moving, that the galaxy is a dynamic system, constantly changing, constantly evolving, though on timescales so vast that human minds can barely comprehend them. Around the main galaxy, you notice smaller galaxies, satellite galaxies, dwarf spheroidals, and irregulars, each containing millions or billions of stars, all bound by gravity to the larger galaxy, orbiting it over billions of years. Some of these dwarf galaxies are being torn apart by tidal forces, their stars stripped away and absorbed into the larger galaxy, a process of cosmic cannibalism that has been happening since galaxies first formed. You drift farther out, and the galaxy shrinks, becoming smaller against the backdrop of space. Now you can see other galaxies, dozens at first, then hundreds, then thousands. Each one is a vast collection of stars, similar to the one you just left, each one containing billions of suns, trillions of planets, and perhaps countless forms of life. The galaxies aren't distributed randomly. They form patterns, structures, groups and clusters, superclusters and filaments. Gravity has organized them over billions of years, pulling them together into these enormous structures, the largest objects in the universe. You see the local group, the small cluster of galaxies that includes the Milky Way and the Andromeda galaxy, along with dozens of smaller companions. Andromeda is approaching the Milky Way, pulled by mutual gravity, and in a few billion years, the two will collide and merge, creating a new, larger elliptical galaxy. But that collision will be gentle, despite its scale. The stars are so far apart that few, if any, will actually collide. The galaxies will pass through each other like ghosts, their gravity mixing and merging the two populations of stars into one. But that's future time again. Here and now, the galaxies are still separate, still beautiful in their individual forms. You continue outward, and the scale becomes almost incomprehensible. You can see the Virgo supercluster now, a vast collection of galaxy clusters containing tens of thousands of galaxies, spread across more than 100 million light-years of space. The Milky Way is just one galaxy among thousands, a small part of this immense structure. And beyond Virgo, you can see other superclusters, vast concentrations of galaxies separated by enormous voids where few galaxies exist. The universe at this scale looks like a cosmic web, with galaxies concentrated along filaments and walls, surrounding empty regions that contain almost nothing. This is the large-scale structure of the universe, the result of tiny fluctuations in density in the early universe, amplified by gravity over billions of years into the cosmic web you see now. It's beautiful in an abstract way, this pattern of matter and emptiness, light and darkness, structure and void. You float here, taking it all in, and you feel simultaneously insignificant and connected. Insignificant because you're so small compared to these structures, a single conscious being contemplating structures made of trillions of stars. But connected because you're made of the same stuff as all of this. The atoms in your body were forged in the hearts of stars, scattered into space by supernovae, and eventually incorporated into planets and life. You are literally made of stardust, a way for the universe to know itself. The thought is comforting rather than overwhelming. You're part of this. You belong here. Every atom in your body has a cosmic history stretching back to the Big Bang. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it was created inside stars and scattered into space, eventually finding its way into you. You begin to drift again, moving in a direction that feels like backward, though in space there's no real backward or forward, no up or down. You're moving through time as well as space now, watching the universe change around you. The galaxies are moving, rushing away from each other, driven by the expansion of space itself. The universe is getting bigger, and as it expands, it cools. But you're moving backward through time, watching the expansion reverse, seeing the universe contract, heat up. The galaxies move closer together. The cosmic web becomes denser, more compressed. You pass through epochs of cosmic time, 2 billion years ago, 5 billion years ago, 10 billion years ago. You're watching the history of the universe unfold in reverse. Galaxies become smaller, less organized. The grand spirals and ellipticals of the present become the irregular, chaotic protogalaxies of the early universe, still forming, still merging, still finding their final forms. Stars become younger. The old red giants and white dwarfs of the present become young, hot, blue stars in the past. You're moving back toward the beginning, toward the time when the first stars ignited. You pass through an era when there were no stars at all, just clouds of hydrogen and helium, slightly denser in some regions than others, beginning to collapse under their own gravity but not yet hot enough to ignite nuclear fusion. The universe is dark during this epoch, lit only by the fading glow of the Big Bang itself, slowly cooling, slowly organizing into the structures that will eventually become stars and galaxies. And then you reach the cosmic dark ages, a period lasting hundreds of millions of years when the universe was truly dark, the last light of the Big Bang having faded, the first stars not yet born. The hydrogen gas glows faintly in infrared, but to human eyes, this would be an epoch of almost total darkness. You continue backward, and the darkness begins to brighten. You're approaching the recombination era, when the universe cooled enough for electrons to combine with protons to form neutral hydrogen atoms. Before this moment, the universe was opaque, filled with free electrons that scattered photons, preventing light from traveling far. After this moment, the universe became transparent, and light could travel freely. You watch recombination happen in reverse, atoms breaking apart into free electrons and protons, the universe becoming opaque again, glowing with thermal radiation. The temperature is rising as you move backward through time, a few thousand degrees now, hot enough to glow orange, then yellow, then white. The light becomes brighter and brighter as you continue backward. There are no structures now, no galaxies or stars or planets, just a hot, dense soup of particles and radiation, expanding and cooling, but you're watching it contract and heat up as you move through time in reverse. The temperature rises to tens of thousands of degrees, then hundreds of thousands. The universe is too hot for atoms to exist now. Matter exists as plasma, nuclei, and free electrons moving independently. The light is so bright you should be blinded, but somehow you can still perceive, still witness. You pass through the era of Big Bang nucleosynthesis, when the universe was hot and dense enough for nuclear fusion to occur everywhere at once, creating the first helium and lithium from primordial hydrogen. The nuclear reactions flash around you like cosmic fireworks, millions of reactions per second throughout all of space. The temperature continues to rise as you move backward, millions of degrees now, then hundreds of millions. The universe is smaller, denser, hotter. Particles that exist now are being created and destroyed in the intense heat and energy. And then, as you approach the very beginning, time itself becomes uncertain. The laws of physics as you understand them begin to break down. Quantum effects become important at cosmic scales. The universe was so hot, so dense, so small that the four fundamental forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were unified into a single force. You're approaching the moment of the Big Bang itself, the beginning of space and time, the origin of everything. But as you get closer, the concepts become harder to grasp. What does before mean when time itself began at this moment? What does smaller mean when space itself didn't exist yet? You reach the Planck epoch, the first 10 to the power of -43 seconds of the universe's existence, when the universe was so hot and so dense that current physics cannot describe what happened. Time and space themselves were quantized, fluctuating, undefined. And then, the beginning. Or perhaps not a beginning but a transition, a moment when the universe as we know it emerged from a previous state that we cannot describe or understand with current knowledge. You float here, at the origin of everything, and you feel a profound peace. This is where it all began. The stars, the galaxies, the planets, life, consciousness, you. Everything that exists came from this moment, this singular event that created space and time itself. And then, gently, you begin to move forward through time again. The universe explodes outward, expanding rapidly in the cosmic inflation that occurred in the first fraction of a second. Space itself stretches, quantum fluctuations are amplified to cosmic scales, creating the tiny differences in density that will eventually become galaxies and clusters of galaxies. The expansion continues, but inflation ends, and the universe enters a more sedate expansion. The universe cools, and particles begin to form, first quarks and gluons, then protons and neutrons, then electrons. The fundamental particles that make up matter crystallize out of the cooling energy of the Big Bang. Big Bang nucleosynthesis occurs again, this time in the forward direction, creating the primordial elements, mostly hydrogen, some helium, a tiny bit of lithium. These are the raw materials from which everything else will be built. The universe continues to expand and cool. After about 380,000 years, it cools enough for recombination to occur. Electrons and protons combine to form neutral atoms, and the universe becomes transparent for the first time. The light from this era will eventually become the cosmic microwave background radiation, still detectable today, the oldest light in the universe. The cosmic dark ages begin. The universe is dark but not empty. Gravity is working on the tiny fluctuations in density, pulling matter together, creating denser and denser regions. Clouds of hydrogen gas collapse under their own weight, heating up as they collapse. And then, perhaps 100 million years after the Big Bang, the first stars ignite. These are not stars like our sun. They're massive, hot, blue, and short-lived. They burn bright and die young, living for just a few million years before exploding as supernovae. But in their brief lives, they transform the universe. They create the first heavy elements, carbon, oxygen, nitrogen, iron, forging them in their cores through nuclear fusion and then scattering them into space when they explode. These heavy elements mix with the primordial hydrogen and helium, enriching the gas from which the next generation of stars will form. Each generation of stars creates more heavy elements, slowly changing the composition of the universe, making planets possible, making life possible. The first galaxies form, small and irregular, colliding and merging, growing larger through cosmic cannibalism. Supermassive black holes form at the centers of galaxies, growing as they consume gas and stars, becoming the engines that will power quasars and drive galactic evolution. You watch as our own galaxy takes shape, condensing from a cloud of gas enriched by previous generations of stars. The Milky Way forms its disk and spiral arms, stars condensing from the gas, planets forming around many of them. About 4.6 billion years ago, in an unremarkable spiral arm of an unremarkable galaxy, a cloud of gas and dust begins to collapse. At its center, a new star ignites, a yellow dwarf star, the Sun. Around it, a disk of material gradually coalesces into planets, rocky ones close in, gas giants farther out, with asteroid belts and comet clouds filling the spaces between. The third planet from this star is just the right size and just the right distance to have liquid water on its surface. Over hundreds of millions of years, complex chemistry occurs in this water. Molecules combining and recombining, eventually creating self-replicating molecules, the first primitive life. Life evolves, slowly at first, then faster. Single-celled organisms dominate for billions of years, gradually changing the planet, creating an oxygen atmosphere. Then multicellular life emerges, and evolution accelerates. The story of life on Earth unfolds: the Cambrian explosion, the colonization of land, the age of dinosaurs, their extinction, the rise of mammals, and eventually, the emergence of humans. All of this cosmic history, from the Big Bang to the present moment, has led to this, to you, floating peacefully in this imagined space, contemplating the universe that created you. You drift forward to the present moment, returning to the star field where you began. The stars shine around you, steady and peaceful. You're back among the familiar constellations, though from this perspective they look different than they do from Earth. You notice one star in particular, a yellow star, neither the brightest nor the dimmest, just one star among billions. But it's special because it's the Sun, your sun, the star that makes life on Earth possible. You drift toward it, and it grows brighter, larger. The other stars fade as the sun's light dominates. You can see its surface now, not smooth but turbulent, covered with convection cells like a boiling pot magnified to cosmic scale. Sunspots dot the surface, regions where magnetic fields suppress convection, making them cooler and darker than their surroundings. Prominences arc from the surface, loops of plasma following magnetic field lines, some of them large enough to engulf multiple Earths. Solar flares erupt occasionally, releasing bursts of energy and particles into space. The Sun is not a static object, but a dynamic, living thing, constantly changing, constantly active. You pass close to the Sun, feeling its warmth, its light, its life-giving energy. This star has been burning for 4.6 billion years and will continue for another 5 billion, steadily converting hydrogen into helium in its core, releasing energy that lights and warms an entire solar system. You move away from the Sun, outward through the solar system. You pass Mercury, small and cratered, baked by its proximity to the Sun. You pass Venus, shrouded in thick clouds, its surface hidden from view, a hellish world of extreme heat and pressure. And then you see it, Earth, the pale blue dot, suspended in a sunbeam. From this distance, it's small and fragile looking, but it's beautiful. Blue oceans, white clouds, brown and green continents. Somewhere on that small world, billions of people are living their lives, loving and working, dreaming and hoping, completely unaware that you're out here, looking back at their home. You drift closer, and the earth grows larger. You can see details now, the swirl of a hurricane, the brown plume of a river emptying into the ocean, the white caps of mountains, the dark green of forests, the lights of cities on the night side. You enter the atmosphere, a thin shell of air that makes life possible, that protects the surface from harmful radiation, that creates weather and climate and the conditions for life. The sky brightens from black to deep blue as you descend through the upper atmosphere. You're falling now, but gently, peacefully, like a feather drifting down. The ground below becomes clearer. You can see individual features, forests and fields, rivers and roads, houses and buildings. You descend through clouds, emerging below them to see a familiar landscape. It's evening, and the sun is setting, painting the sky in shades of orange and pink. The day is ending, and the world is settling into the peace of night. You continue descending until you're hovering just above the ground, in a place that feels safe and comfortable. It might be a place you know, or a place you've dreamed of, or a place that exists only in this moment. It doesn't matter. What matters is that you're here, back on Earth, back home. You settle gently onto the ground, feeling solid earth beneath you once more. The cosmic journey is complete. You've traveled from the Big Bang to the present, from the edge of the observable universe to your own backyard, and now you're here, at rest, at peace. The stars are coming out above you as the sky darkens. The same stars you floated among, the same stars that have been shining for billions of years, the same stars that will shine for billions more. They're so far away, yet their light reaches you, a connection across space and time. You lie down on the ground, looking up at the emerging stars. The grass is soft beneath you, and the earth is solid and supporting, so different from the weightlessness of space but comforting in its solidity. As more stars appear, you recognize constellations, the Big Dipper, Orion's Belt, Cassiopeia. These patterns have been recognized for thousands of years, seen by countless generations of humans, all looking up at the same sky, all feeling the same wonder. The Milky Way becomes visible, a pale band across the sky, and you realize you're looking at your home galaxy from the inside, seeing the combined light of billions of stars too distant to see individually. Somewhere in that band is the galactic center you saw from outside, the spiral arms you traced with your vision, the nebulae where new stars are being born. You understand now, in a deep way, your place in the cosmos. You are small, yes, but you are also part of something vast and beautiful. The atoms in your body were forged in stars. The elements that make you possible, the carbon, the oxygen, the nitrogen, the calcium, the iron, all of it came from stars that died before the sun was born. You are made of stardust, and you will return to stardust. Your atoms will eventually rejoin the cosmos, perhaps to be incorporated into new stars, new planets, new life. You are a temporary arrangement of matter that has become conscious, a way for the universe to observe itself, to appreciate its own beauty. The thought is comforting rather than frightening. You are connected to everything, to every star you saw, to every galaxy, to the cosmic web itself. You are part of the universe's story, a small part but a part nonetheless. The night is fully dark now, the stars brilliant overhead. You feel the earth rotating beneath you, a reminder that you're on the surface of a planet spinning through space, orbiting a star, which is orbiting the center of a galaxy, which is moving through the cosmos along with billions of other galaxies. Everything is moving, yet everything feels still. You are moving through space at thousands of miles per hour, yet you feel at rest. The contradiction doesn't bother you. It's simply how things are, the nature of the universe. Your breathing has become slow and deep, matching some cosmic rhythm you can't quite name. Each breath connects you to the universe. You're breathing oxygen created inside stars, breathing in atoms that have existed since the Big Bang, breathing in and out the same air that all life on Earth shares. Your eyelids grow heavy. The stars blur slightly, becoming soft points of light against the darkness. The cosmos continues its ancient dance above you, stars burning, planets orbiting, galaxies spinning, the universe expanding. But you are still, at rest, at peace. You think of the journey you've just taken, from the Big Bang to this moment. Billions of years compressed into this one night, all of cosmic history leading to this single, peaceful moment. And now, finally, you rest. Not just physical rest, but cosmic rest, existential rest. You are exactly where you're meant to be, exactly when you're meant to be here. The universe has been unfolding for 13.8 billion years to create this moment, and you are here to experience it. The stars shine on above you. The earth spins beneath you. The galaxy rotates around you. The universe expands around you. And in the center of all this motion, all this vastness, all this cosmic dance, you rest. Rest now, child of the stars. Rest in the peace of the cosmos. Rest in the knowledge of your connection to everything. Rest in the embrace of space and time. Rest in the comfort of stardust. Rest knowing you belong to the universe. Rest as the cosmos rests between moments. Rest as stars rest between their birth and death. Rest in the eternal peace of existence. Rest now. Rest.